So hello all, welcome to my channel. So let us talk about interval estimation. Let's understand what interval estimation is. So interval estimation is a statistical technique used to estimate range within which a population parameter is expected to lie based on a sample data. This range is called confidence interval. Interval estimation provides an estimate of the parameter along with an indication of the estimate's reliability, which is not provided by a single point estimate. So let us understand this. What does it mean? So we know that this is our normal distribution diagram, okay, and we know in the middle lies our mu. So when we do sampling, when we treat samplings, so this relies under this and it is called as sampling distribution. So when we do the sampling distribution, in the case of interval estimation, what happens is that a particular range or a population parameter is expected to lie based on a sample data. So it lies over here, okay. So this much portion, whether where it is lying, this portion is called as CI, which is confidence interval. So based on these confidence intervals, we will calculate or we will estimate our interval, okay. So because a point estimator cannot be expected to provide the exact value of the population parameter, an interval estimate is often computed by adding and subtracting a margin of error. So we all know in the case of this that the point estimator cannot be expected to provide exact value. It does not gives us exact value. That is why what we do, we calculate the margin of error. So we do both the things, we add and subtract the margin of error with our point estimate. So what does mean by point estimate? Basically, point estimate means it is our x bar, okay, which is mean or sample mean. This is our point estimate, right? So what we do, we add and subtract the margin of error with our sample mean. That's it. Moving on. So we have this case, first case, which is population mean sigma nu. Okay. So we know that population mean is denoted by mu and sample mean is denoted by x bar. But let us understand what this definition says. To construct an interval estimate of a population mean, either the population standard deviation or the standard sample deviation S must be used to compute the margin of error. Okay, so in order to compute the margin of error, we need both these things. We either need sigma or we need the sample standard deviation, which is denoted by S. Sigma means population standard deviation. Okay, so yeah, that's it. Now, although is rarely known exactly, historical data sometimes permit us to obtain a good estimate of the population standard deviation prior to sampling. So based on the historical data, what it says, historical data gives us a good population standard deviation, which is our sigma. Okay. Now in such case, the population standard deviation can be considered as no exactly correct when we have the historical data, and if we compute it directly, the uh, standard deviation will be termed as population standard deviation. Okay, moving on. So what is alpha? This is another terminology. So in interval estimation, especially we use this term alpha. So particularly in the context of confidence intervals, alpha represents the significance level of the interval. It is the probability that the true population parameter lies outside the confidence interval, as I mentioned earlier. Okay, let's understand this with the help of diagram. This is our confidence interval. So, and this is the outside portion. Here lies our alpha. Okay. Now, in other words, it quantifies the level of risk or the likelihood of making an error by saying that the interval contains the population parameter when it does not. So here we have a formula. Alpha is the complement of confidence level or confidence interval. So let's say we have CI as 95 or 95%. Yes. So what we'll do, how we'll calculate the alpha? We will subtract this CI by 1 and we will get this. So here is the answer. We do 1 minus 95%, we get 5% as our alpha. This is 5%. Okay. So let's understand this alpha with the help of visualization. What exactly I was meant to say by alpha. This is our normal distribution diagram. Okay. And specifically here I have mentioned that this portion is our confidence interval or confidence level. Okay, so let's say this is our 95% confidence interval which is given to us in a particular case, business case. Correct. Now the portion, this remaining portion which I am marking by red color is our alpha by 2. If you add both of these, this is our alpha. Okay, so as from the beginning I was telling you that the whole normal probability is of 100%, but specifically only this much portion we are taking it as for our confidence level. So this portion is 95%. So when we subtract it from 100, we get 5%. 100 minus 95 comes 5. So this is our 5% which is remaining. This is our alpha. So, but this is the combined. Okay. So this much is our 0.25 or 2.5%. That is why we are doing here alpha by 2, because we know the total alpha is 5, but this left side of it is 5 by 2, that is 2.5%, and here also same 5 by 2, 2.5%. So this is the calculation of alpha, and this is the representation of alpha which I just did for your better understanding. I hope this is all clear to you. Moving to the next slide, what it says. Okay, so I'm not going to read this whole thing. You only have to remember this simple thing, which is our formula to calculate the margin of error. Okay, so this thing is our margin of error. Alright, so margin of error is equals to Z alpha by 2 into sigma divided by root n, small n. Okay, we are using this formula because we are in the sigma known case. This is what I have written over there. Interval estimation of population means sigma known case. Okay, so I have also told you the alpha thing, how we computed alpha, how we derive alpha, and what we do in order to get the alpha value. Okay, This is our margin of error. Then X bar, we know that it is our sample mean. So what we do is, at the end of every problem, we calculate the upper limit and lower limit. Okay, so let's say our margin of error comes around 2 and we have X bar as 40. So our upper limit will be 40 plus 2, lower limit will be 40 minus 2. This will be 42, this will be 38. Okay, moving on. So here is our important table. Okay, what I have written over here is values of Z alpha by 2 for the most commonly used confidence level. So these are the most commonly used confidence levels, which are 90%, 95%, 99%. Okay, so we talked about the 95% confidence level and we didn't talk about this. These are also simple. If you do the subtraction from 100 minus 90, we get the 10%. In the same case for 100 minus 99, we get the 1% as our alpha. Okay, so yeah, this is our alpha. So we got these alpha values. Like that we got Z alpha by 2. Now the question comes in, what is Z alpha by 2? Okay, so these values are our probability, right? For example, I'm taking the example of 95 only for the better understanding. This is 95. Now here is our alpha by 2. Here also is our alpha by 2. Okay, this portion. So this is our 2.5%. And these are our both of these, like the complete inside portion of this bell-shaped curve or normal distribution curve is our probability, which is our area. Okay, so when you will check the Z table, in the Z table we have the following ranges like this: 1.0, then you have 1.1, yes, and then you have 1.2, 1.3, so on. And here you have 0.0, then you have 0.01, then you have 0.02, so on. And in the inside of this table includes the area, right? So for 2.5% of area we get a Z score of 1.960. So when you will go and check the Z score of 1.960, you will find that the probability in the Z table is mentioned as 2500. Okay, this is what you will find. Okay, so this is our Z table, and as I was talking about 1.96, right? So here is our 1.96 and we want 1.960. So see, this is 0.250. If you multiply this into 100, we get 2.5%, right? So 2.5% is our area and this is our alpha by 2. For this particular area, we have a Z score as 1.960. Alright, hope this is clear to all. Anyway, so moving on to the next slide, we have some important keywords which we discussed. So starting from confidence interval and confidence level. Both of these are same. When the business case will include these words, they will mention something like 95% confidence level or interval, 99%, 90% they will give. Okay. Then we also discussed about margin of error. The formula of margin of error was said alpha by 2 into sigma divided by root n. Then we talked about sigma known case. We only targeted this case. So in a sigma known case, we always use z-score table. This is a very important point to be noted. Okay. And then I also told you about upper limits and lower limits. So the formula to calculate upper limit is x bar plus margin of error, and for lower limit x bar minus margin of error. So the first slide shows point estimate plus minus margin of error. Why? In order to get the estimation right. As the definition was saying, it is impossible to get exact interval estimation. That is why we calculate these two limits in order to get the at least appropriate interval estimation. Let's understand this topic in a deeper sense by solving some problems. So a problem says that a simple random sample, small n, of 40 is given to us. Okay, so we have 40 as our sample size, results in a sample mean of 25, means x bar is given. Population standard deviation, that means sigma is given, which is 5. So let's solve the case A. What is the value of standard error of the mean? So we know that standard error of the mean means sigma x bar. So the formula to calculate standard error of mean is Okay, so the formula to calculate the standard error of mean is equals to sigma divided by under root of n, which is n divided by root 25. So this is going to be 1. Okay. Now B is asking us to what B says, at 95% confidence, what is the margin of error for estimating the population mean? Very simple. Let's draw the diagram first. This is our normal distribution curve. In the middle lies our x bar, which is 25. Okay, and this is our 95% confidence, the whole portion. Now here lies the remaining portion is our alpha by 2. Alright. Okay, so how do we calculate the alpha? We have our formula as 1 minus 0.95, which is 0.05. This is our alpha, and the alpha by 2 will be 0.025, which is 2.5%. So this is our 0.025 or 2.5%. Okay, so we have calculated alpha, which is 5%. We also calculated alpha by 2, which is 2.5%. Now what we need is to calculate the margin of error. I'm writing in the short form as MOE, margin of error. So we have a formula as set alpha by 2 into sigma by root n. This we have already calculated. Okay, sigma by root n, which is our standard error. We only need set alpha by 2. So Z for 0.025 into sigma by root n, which is going to be 1.960 into 1. Okay, which means our margin of error is 1.960. Correct? Now the last step in the conclusion, what we do is we estimate the margin of error for the population mean. In order to estimate that, we calculate the upper limits and lower limits. So upper limit is going to be x bar plus MOE, lower limit is going to be x bar minus MOE. This comes around 25 plus 1.96, 25 minus 1.96, which is 26.96, and this will come around something. Okay, so this is it. This is how we solved this problem from the beginning. Very simple and easy concept to remember. We know that how this value came. This value is mentioned in our Z table, 1.960, or else we have the specific table which I gave over here. From this you can also calculate the values. Okay, anyways, moving on to the next problem, which says a simple random sample of 50 items from a population with sigma 6 results in sample mean of 32. We have sample size as 50, we have sigma, which is population standard deviation, as 6, and we have sample mean, which is x bar, we have dash 32. Then A, which is saying that construct a 90% confidence interval. So the middle one portion is going to be 90%. In the middle lies our mu. So if it is 90, then we are left with the alpha, which is going to be 10%. Okay, so if you do the alpha by 2, we get 5%. So this is our alpha by 2, which is 5%, and this is also going to be 5%, alpha by 2. Okay, now the next step is to calculate margin of error. So margin of error is going to be Z alpha by 2 into sigma x bar. Okay, which is Z alpha by 2 is our 0.05, and this is going to be our sigma by root n, which is 50. Okay, so this is how you can calculate the margin of error. After calculating the margin of error, we calculate the upper limits and lower limit. So the upper limit is going to be x bar plus margin of error, and lower limit is going to be x bar minus margin of error. So 32 plus whatever the margin of error is, and 32 minus margin of error. Hope you got a clear understanding about the this topic, interval estimation. I hope you will solve the next problems. In the coming videos, I will introduce you to some of the business case problems. These are the basic problems which I explained so that you will get a clear understanding of what interval estimation is. Alright, so see you in the next video. I hope you will calculate these things, and this B and C is going to be your task and your objective. Go and solve it and post the appropriate answers in the comments below. Goodbye, see you again. See you in the next video.